Chapter 8 of Thomas Kuhn's The Structure of Scientific Revolutions is titled The Response to Crisis, whereas in Chapter 7 Kuhn focuses on how the crisis in science arises. In this chapter he elaborates on how the scientific community responds to this crisis. He makes the interesting point that in criticizing one theory, the scientist must propose an alternative. Otherwise, this is not the pursuit of science. What is also interesting is that he suggests that when this competitive process ends, the branch of science becomes static, and in the example he gives, it becomes a research tool. Kuhn suggests that there are always discrepancies, even in the most successful of paradigms. With a move towards crisis, there are increasingly divergent explanations, and there is a loss of identity within the field. Indeed, Kuhn maintains that all crises involve a blurring of paradigms. The crises are closed in one of three ways. In the first case, the crisis is handled. In the second scenario, there is resistance to radical approaches. In the final scenario, the crisis leads to the emergence of a new candidate for paradigm. Kuhn then goes on to discuss commentators on the field who refer to Gestalt's theory, in which a visual perception is dependent on the whole, rather than part of an object. So if the reader looks at the cube below, the lower square face can be interpreted either as sitting at the front of the cube or the back of the cube. In both cases, the square takes on a different meaning within the whole object that is perceived. In the same manner, Kuhn suggests that new paradigms lead to a different way of seeing a body of empirical facts. He is quick to point out, however, that this is a crude analogy and that scientists do not quickly switch back and forth between paradigms. Nevertheless, it illustrates the essence of his arguments well. Kuhn then goes on to say that the scientists, having identified the anomaly central to a crisis, will go on to explore the anomaly and to better characterize it. In crisis, speculative theories multiply and increase the chance of a successful paradigm being reached. He also suggests that philosophical inquiry into assumptions can challenge some of the tenets of the current paradigm. Finally, Kuhn finishes by commenting that many scientists involved in scientific revolutions are deeply immersed in crisis, and that they are either very young or new to the field, which he interprets to mean that their thinking has not been shaped by the component rules of a paradigm. However, Charles Darwin would be a notable exception, having published on the origin of species at a mature age and with a comprehensive knowledge of the related fields in biology. Nevertheless, there are numerous counterexamples, and the main result of this chapter is that Kuhn provides the reader with very effective tools for thinking about science in transition. One thought I had here was that in the very early stages of a science, there must be a lot of theories that are initially developed, but which are quickly shaped by the experimental facts. In this way, many theories would exist before quickly falling to experimental findings, in which case there would be a survival of the fittest theories which are tested against each other. This has a number of implications. Firstly, that a philosophical system might define this pre-science phase, in which a large number of theories exist without being tested against the experimental facts. The brain's analytic and other abilities are used as an alternative to hypothesis testing in the real world in order to generate realistic solutions based on experience and intuition. As time proceeds, and assuming the system has an efficient or effective memory, and scientific inquiry produces a growing body of empirical facts, the competitive process in which proponents of different models challenge each other's models and refine their own leads to fitter models using evolutionary terms. However, these models are adapted to the empirical facts, which in turn are a byproduct of the initial inquiries in this area. In this manner, mathematics might offer the best starting conditions for this philosophical inquiry, as these starting conditions give philosophical inquiry the least opportunity for diverging from reality using such an approach. Secondly, fitter theories might well diverge significantly from an explanation of reality depending on their starting conditions, although there might be other phenomena which curtail that line of inquiry as this divergence becomes more evident. What this would also mean is that the development of the most effective scientific theories is not only a measure of how effectively a theory fits with the empirical data, but is also a marker of how effectively a theory keeps the focus on the empirical data in which the theory initially flourished, as well as a measure of how effectively the theory recruits and retains proponents.